look into the sky at night.
Good evening. Last year, we devoted several of these Sky at Night programs of ours to the planet Mars because of the Viking landings there. And I think it's rather a good time to come back to Mars now because we have got some new and rather interesting information. So let's begin by having a look at what is known as the ecosphere. And this is the region surrounding the sun where, other things being equal, conditions are neither too hot nor too cold for life of the kind we know to exist. It's shown there as a shaded band. The sun's in the middle. You can see that Mercury, not named there, and Venus are inside the ecosphere. Venus admittedly only just inside. The Earth is in the middle, which is why we're here. And then right on the outside comes Mars. And beyond that, the temperature is very much too cold. So on those grounds alone, other things being equal, we would expect to find our kind of life only upon the Earth and possibly upon Mars. The others are either too hot or too cold or unsuitable in other ways. So let's begin by having a close look at two regions which are superficially just a bit alike. This is Australia, one of the Australian deserts, a rock-strewn sea. This is Mars, one of the pictures sent back by Viking lander number 1 in the area of Garry. And once again there you can see this rock-strewn surface, and obviously the main difference is that the Martian sky is pink because of the dust spread so finely through the atmosphere. Now, I said this was a good time to come back to Mars, and I think that's true, if only because it's now very nicely on view in the evening sky. It's in the general area of Orion, actually in the constellation of Gemini, the twins. It's pretty bright, brighter than any of the other stars apart from Sirius. Not, of course, so brilliant as the planet Jupiter, which is higher up, but rather just about the same as Saturn, which is in Leo. But you can't mistake Mars because it is so red. And telescopically, you can see quite a bit on it. I thought you might be interested to see my own observation book, because I've been observing Mars for a long time now. These drawings were made in January with my 15-inch reflector, and I'd like you to notice that dark area, which is one of the famous patches upon Mars, once thought to be sea, now known to be nothing of the kind. It isn't even vegetation. And there we have the North Polar Cap. And in these drawings of mine, I usually put south in the top, which is how a telescope shows it. And these caps are of fundamental importance. But there is a limit to what Earth-based telescopes will show upon Mars, because after all, it's a small world, only about twice the diameter of the moon, and it never comes within 34 million miles of us. This year, it's not been within 60 million. So we do depend upon the probes. Each Viking consisted of an orbiter and a lander, and the landers came down in two widely separated regions. The first one descended in the ochre plain of Garry. There it is. That was selected as being one of the safer-looking areas, and it turned out to be a rock-strewn landscape. And there again you see the characteristic pinkish sky. Viking number 2 came down a long way away in another plain, Utopia, which we thought was going to be rather different from Garry, but in fact turned out to be very much the same, which was a distinct surprise. Now, those landers have been operating now for 18 months. And that's nearly one Martian year of 687 Earth days. And in fact, one Martian year is up on June the 11th by our calendar. So we have had the chance now to get long-term observations. The orbiting sections are expected to go on transmitting until next February at least. They will probably crash down upon Mars eventually, but certainly not for a very long time. And the landers are still pretty well in full operation. So, because we've now been able to get long continued observations from the surface of Mars, we've learned a great deal more than we knew last time we devoted a Sky at Night program to it. And at this stage, I am delighted to welcome back our two Mars experts who were with me in all our programs last year, Professor Geoffrey Eglinton and Dr. Garry Hunt. Welcome back, gentlemen. Well, we've certainly learned a great deal, and in particular, I think, about the atmosphere. What would you say about that, Garry? This is your line.
Well, I think we've been fortunate to have seen the seasons on Mars, which we've learned a great deal about the atmosphere. We don't understand it all, And of course we now have the opportunity of going on for a few more months, and perhaps we'll see the dust storm season once more on Mars, which should occur in December and January.
I think in some ways the atmosphere has been rather a disappointment. After all, it is very thin, and much too thin for us to breathe, and made up chiefly of carbon dioxide. But at least we're learning. Geoffrey, I know you've been particularly concerned with this search for life, which is still a bit inconclusive, and I've been very interested in these recent experiments that have come in from, of all places, the Antarctic.
Well, the reason, Patrick, is that before Viking, the Americans were very interested in the Antarctic because it provided a test for their life detection systems that they eventually sent in Viking. And they found there were these valleys called the dry valleys of Antarctica, which are extremely barren places. The rocks have no obvious growth on them at all. Nothing seems to live there, and even when they delved into the soil and with the microscope and also by doing culturing experiments before Viking, they could find really nothing at all.
So what they did, I gather, was to break the rocks up.
Well, now since then they've taken a piece of the rock, and this was a husband and wife team from Florida of all places, went down there and chopped off a piece of rock, made a thin section, looked at it under the microscope, and lo and behold, there are lichens, these small microscopic plants growing inside the rock, several millimeters inside the sandstone rock, on the little grains of sand. So they found for themselves a little microclimate safe from the Antarctic weather. And of course, these Americans have suggested that it's quite possible that on Mars there could be Martian organisms hiding beneath the surface of the Martian rocks.
Which, of course, wouldn't be detected from Viking. It's a fascinating theory, but of course the poles of Mars are not the same as Antarctica. Have you got any faith in it yourself?
Well, I think that the problem with it is that the Vikings did sample the soil, and in the soil there were small pebble-like pieces which would have been good hiding places for this type of organism, but of course the results were negative.
And of course the other factor to bear in mind is we have the dangers here of ultraviolet sunlight.
Yes.
We are protected on the Earth from that by the presence of ozone. We don't have so much ozone in the Martian atmosphere, so any life system that could survive has got to find a way of either protecting itself or in fact overcoming the dangers of the harsh ultraviolet rays from the sun.
And this, of course, is the difference between the Martian atmosphere and our own. So, what do you think now, Geoffrey, about the analysis of the surface materials themselves? Because this also is highly relevant to the life problem.
Yes, well, it's interesting to look at the surfaces now with some of the information that's come in. If we go back to one of the early pictures, I think it's Viking 1, we can see there a desert landscape with sand dunes and rocks of a variety of types, actually, and even sort of ridges on the horizon. Well, we now know, or at least it's pretty certain, that this is an area where there are volcanic rocks, and the ridge is in fact a volcanic ridge.
And this, of course, is the area from which the scoop samples were picked up and analysed.
Yes, they took samples with a scoop into the soil. And this is a very important point, you see, because it's now believed that that soil really is a sort of Mars-wide distribution. It's blown everywhere by the winds, and it's not really local in composition. So that you can have quite different rocks roundabout and a sort of homogeneous Mars-type soil which is being analysed. So that we've got to remember that. We're analysing something which is rather an average for Mars.
What are the rocks really like?
Well, they're certainly of volcanic type with vesicles and so on in them, and all sorts of rock crystal types have been recognized with the cameras, and the chemistry has proved very interesting itself. But remember, the chemistry is that of this soil, and all they can do is make guesses at some of the rocks. Well, with the soil, it seems that they have done these tests several times over now, over the Martian year. They've repeated and repeated these chemical tests, and what they show is that indeed there is a response from the Viking Site 1 and Viking Site 2, which is reproducible. And it looks at first sight like living organisms feeding on soup that they're provided with by the by the Viking lander on Mars, but in fact looks much more like some sort of chemistry going on.
So in fact, it's fair to say that we have no proof whatever of any life upon Mars as yet. I remember one comment made by one of the leading scientists some time ago, there should be life on Mars, but we can't find any bodies. And I think we've got to say now that probably, well, certainly the Vikings won't tell us, because these particular experiments have ceased to operate. What else has come out of the landers, Geoffrey?
One very surprising thing, and that is that they've turned the cameras onto one of the Martian moons that's been going over across the surface. and they've been able to get some very interesting information about moons.
I think these two moons of Mars are fascinating. There are two of them, of course, Phobos and Deimos, discovered way back in 1877. They are not a bit like our moon. They're irregular chunks of rock, less than 20 miles across. And this wonderful photograph of Phobos was taken from the Viking, and as you can see, it is rather like a potato in shape, with craters everywhere. And a lovely close-up view shows these extraordinary striations. And certainly the moons of Mars are totally unlike ours. They are more like meteorites in composition.
Yes, indeed. This, the results from the Viking lander cameras using spectral reflectance and so on, and also from the orbiter, indicated the moon has this one, particular one, Phobos, density of about 2, which is very light,
yes.
But its surface is extremely dark, and the nearest one can come to it is the objects of the type called carbonaceous chondrites.
Special kind of meteorites, in fact.
Yes. I have one here provided by the British Museum of Natural History, and this one fell in Australia on the Earth 1969, and it's quite rich in carbon and water and so on, and as you can see, very, very dark, and it's believed that the Phobos and presumably the other moon are similar.
I have no doubt that Phobos and Deimos are basically of the same kind. And you know, Geoffrey, I think this gives support to the theory that they are captured asteroids. Because the asteroids, or minor planets, go around the sun at a greater distance than that of Mars, at least most of them do. They're all pretty small. They may be very like the two Martian moons, and I rather think now that it looks very much as though two of these asteroids came into Mars a long time ago and were captured and haven't been able to get away again. Certainly, let's say they're totally unlike our moon in size, composition, and everything else.
Or in fact, you can throw up the alternative idea that in fact they've come from one asteroid and been broken up. I think what adds credence to that idea is their crater history. They've obviously been very heavily bombarded, and I'd be very surprised for very small objects such as these to have such a large bombarding history as we can see from these pictures.
Well, Phobos has got craters, so has got the outer satellite Deimos, but one thing you're not going to get on these satellites is any evidence of water activity in the past. And I think this brings us right back to Mars, because the more we learn, the more significant past flowing water seems to be, even though you can't have any running water on Mars now.
Yes, that's important because at the moment we know the surface pressure is 7 millibars or 7/1000ths of the surface pressure of the Earth, but we got some clues from the Viking studies of where some of the water is now. For example, the UT crater, which was seen when we were looking for the landing site, shows what's happened, something impacting, caused the crater, it's melted the surface, it's removed the water, which has acted as a fluid agent as the debris has flowed away, causing sort of fluted structure around it. It's quite thin, but you can see a pre-UT crater through that ejecta blanket. Yet when you look in the Chrysae area, you find distinct evidence of past rivers. Not impacts have created these, but obviously water has collected and flown just like rivers. These are dendritic channels.
Well, they look remarkably like rivers. In fact, they look so like rivers that I find it impossible to believe they're anything else. I suppose there's just a chance it could have been cut by very runny lava, but it doesn't look very likely.
I would find that rather difficult to believe. I don't quite could believe that these are dendritic channels. Yet when you come down towards the equatorial region and go down to Valles Marineris, which is this deep canyon, probably cut through tectonic activity, we're looking at the eastern edge. The central crater is the crater Galileo, and here is an area which gets rapidly heated to very high temperatures, as much as 30 degrees centigrade during the summer periods, and cooled a great deal during the winter periods. So it gets rapid heating and cooling, and this sort of mechanism causes the surface material to creep, and we get evidence there of flows, and that flow there was towards the northern part.
It is an incredible landscape, isn't it? Nothing like that on Earth, and those canyons would dwarf anything we have. Even the Grand Canyon of the Colorado would shrink into insignificance beside it. And it seems interesting to me, too, that these are connected with the huge volcanoes. Because after all, Mars has got volcanoes on it, and some of them are real giants. Those are the fastest ridge. They, again, dwarf any of the volcanoes that we have. Look at those two. Even though they're pretty big, aren't they, Garry?
Yes, these are meant to be sort of young volcanoes in the sense they are away from the main sort of Tharsis Ridge, and these were quite spectacular high-resolution pictures indicating enormous activities that must have taken place on the surface during the beginning of Mars.
In fact, all over Mars, you find evidence of volcanic activity, great lava flows and so on. I think now the literature is full of these descriptions of objects as being lava flows.
But to me, the most spectacular of the lot is the one so aptly named Olympus Mons, or Mount Olympus. It used to be called Nix Olympica before you realized what it was. And this is really a giant. The base measures about 300 miles across, and the height of that volcano above the outer country is approximately 15 miles, which is 3 times the height of Everest. And in that rectangle that's been drawn on the picture, right in the middle there is a 40-mile caldera. And I think that picture of the caldera is just about the most incredible thing I've ever seen coming from space.
It really is extraordinary, Patrick.
What about the clouds in these volcanoes, Garry?
Well, of course, we know there's water vapour, a little bit of water vapour in the atmosphere. In absolute amount, it isn't very much. Translate it into a relative humidity, and we find the Martian atmosphere is saturated. It holds as much water vapour as you can at these low temperatures. And a far-encounter picture of Mars showed a cloud over Alcius Mons. You can just see along the terminator this sort of wave, this pattern of cloud against the volcano.
That's another of the great Martian volcanoes, not quite so high as Mount Olympus, but of the same general standard.
But then when you look at Olympus Mons, there was a wonderful example of a whole variety of types of clouds that you could see. And this particular picture of Olympus Mons is in the centre, and you can see mottled-type clouds on either side of it. These are what are called convective clouds, caused by the heating of the atmosphere, and they rise up to about 20 kilometres above the mean Martian surface. Towards the left-hand corner you can see a wave structure, a cloud caused by the topographic variations on the surface, and then in the very top left-hand corner what you and I on the Earth would call cirrus clouds.
What about mists and fogs?
Well, of course, with permafrost layers we expect to find in certain canyons evidence of fogs, and this is precisely what was seen on Viking. There was one particular area, which is shown here, of a fog in these local canyons, and these are seen on several locations. So Mars has a very rich variety of cloud formations, but not the sort of storm systems we find on the Earth.
Well, we know that there can't be any rain on Mars now, and there can't be any liquid water on the surface, but somebody, and I think it was you, Garry, on one of our last year's programs, suggested that you might occasionally get snow.
Yes, snow can probably take place, and it may happen with the advancing North Polar hood, and may result, in fact, in finding carbon dioxide snow occurring on the surface. And certainly there are some clouds that make that a very likely sort of interpretation.
Well, I've been watching Mars pretty closely for a long time, and of course I've seen various obscurations, and I'd like to show you one of these. Well, this is well, I know whether you call it a dust storm or what it is, but I looked at Mars on February the 9th, and there was a rather nice little cloud, quite an obvious thing, and there was an obscuration extending over into the region that we call Tempe, and I gather this was also found from the probe pictures.
Well, in fact, to be absolutely truthful, we got the information from the amateur observers before we got any information from Viking.
I was one, I know.
And in fact, this is where we do say we must have amateurs studying the planets. They can see probably sometimes more, because they look at the entire planet, than we can from a spacecraft. We only see a small area. But the dust storms on Mars have really been incredibly exciting. We have seen so many. The Argyll area was one area where we saw storms much earlier, before perihelion occurred, as you can see located here.
Lovely one localized there on the end of the arrow.
And then after this particular storm, which actually was one that was generated in the global area, we saw wave clouds occurring near the crater Kuiper. This preceded a second global storm, which when we mapped the area around the Tharsis volcanoes, we in fact found, as you can see with the black dots, that many of them collected along a ridge, which in fact is southeast of that particular set of volcanoes. And so in fact you've seen a large number of storms, 36 altogether, and then in the northern hemisphere we again also have seen some storms. These are associated with the northern polar hood, where you get cold fronts, instabilities in the atmosphere, lifting the dust, as you can see in the left-hand corner of the picture.
Of course, these do affect the temperatures and pressures upon Mars.
Well, of course, what is also interesting to think about is how these storms would compare to those you find on the Earth. And here is a picture taken from an Earth weather satellite, and you can see the dust storm over the Gulf of Mexico.
What about the temperatures and pressures?
Well, of course, the dust storms in the atmosphere of Mars are going to affect the whole environment, and if you look at the study of temperature we've done from the Viking landing sites, you can see the top curve shows the maximum daily temperature and the bottom curve the minimum, how the maximum has been reduced during the last storms, the minimum raised. In other words, the average temperature over the course of a day has varied drastically. And similarly, there's been an effect upon the pressure. The pressure maps, you see the dust storms indicated. The second storm produced so much of a disturbance that there was a dip in the average daily pressure, which meant that the way carbon dioxide was being laid down on the poles was being modified.
Well, these polar caps obviously are of fundamental importance. And you know, Garry, to me, one of the most fascinating things is the discovery that the polar caps are not alike. The south cap, we know, does show the greater variations in size, simply because the temperatures in the southern hemisphere are more extreme than those in the north. But it does seem that the southern polar cap is made up of a mixture of ordinary water ice and carbon dioxide ice. But the northern cap, the one we've been seeing this year, is not the same, and that does appear to be essentially water ice with a thin seasonal overlay of solid carbon dioxide. And just why those two caps are different, I do not know. And what about this frost on the lander, Garry?
Well, of course, when the winter polar cap extends, its carbon dioxide is being laid out on it, and we've seen at the Utopia site evidence of what we think is carbon dioxide ice. You can see it here in this picture, the bright areas hiding behind the boulders.
Well, these landers are still operating, so are the orbiters, but this really, is only the beginning, isn't it? So just let's have a brief look forward to what may happen next. And let's examine models of the Martian vehicles of today and tomorrow. There they are. In the middle of those three, we have the present Viking. And the top part is the orbiter, and underneath we have the landing section, which is shown here, protected by the aeroshell, which shielded it during the descent through the Martian atmosphere. Here is the actual lander, or the model of it, which came down on the Martian surface and has sent back all the information we've been discussing. And in the future, we may have something rather different. We may have a lander which can actually move around, in very much the same way that the Russian lunokhod shifted around the surface of the moon. It's equipped with caterpillar treads, and by remote control, these should be adequate to shift the vehicle around and collect information from different areas, which would be a great step forward, and I don't see anything impossible in that.
No, indeed, Patrick, but I think there is another possibility, and that is the return by automatic means of a Martian sample. And this is something that a lot of scientists are pressing for.
Well, of course, we need to find out where we should be sampling on the Martian surface, so we need a future study of the interaction between the atmosphere and the surface. I don't really see why we in Europe couldn't be building the orbiting spacecraft in the mid-1980s.
I hope we do. It would be a great achievement. But although we've learned so much about Mars, there's still a great deal that we don't know. It's a fascinating planet, and I believe it still holds many surprises in store for us. We've simply got to wait and see. And so, from Geoffrey, Garry, and myself, good night.
This BBC book, Sky at Night 5, containing a selection of articles by Patrick Moore, is available from booksellers, price £4.